डियर स्टूडेंट्स, गुड मॉर्निंग। देखिए, धारा हम पढ़ रहे थे बायो सावर्त के नियम के अनुप्रयोग। ठीक है, पहले हमने पढ़ा था सीमित लंबाई के धारावाही मैग्नेटिक फील्ड ड्यू टू ए फाइनाइट लेंथ वायर। मैग्नेटिक फील्ड ड्यू टू ए फाइनाइट लेंथ वायर, देन वी टेक सम special cases for the finite length wire. Then we find the magnetic field at the center of the current carrying circular coil. That is formula is mu naught n I upon 2r. Today we take magnetic field at the axis of a current carrying coil, circular coil. This is a circular coil. This is the center of circular coil. Then this is the axis of the circular coil. What is the axis of a circular coil? A line passing through the center and perpendicular to the plane of the coil is called axis. If we want to find the magnetic field at the axis of the coil, अगर आप किसी कोयल के एक्सिस पर मैग्नेटिक फील्ड फाइंड करना चाहते हैं, कहाँ पर? किसी भी कोयल के एक्सिस पर, तो आप क्या कीजिए, आप कोयल को इस तरह रखिए कि उसका एक्सिस जो है वो बोर्ड के प्लेन में आना चाहिए। मींस हियर द प्लेन ऑफ द दिस कोयल इज पैरेलल टू द प्लेन ऑफ बोर्ड, एंड इन दिस कंडीशन the plane of the coil is perpendicular to the board. Okay, यानी आप ये समझिए, in this condition coil is like that. This is coil and current is flowing like that in this coil, and this is the center and this is the axis of the coil. Now we take any point P on the axis of the coil. At this point we want to find the magnetic field due to this current carrying coil. Current in this coil is I, radius of coil is R. For finding magnetic field at this point P, we take a line element dl here and also here dl. अब ध्यान दीजिए, dl this is the current ऐसे फ्लो हो रहा है, तो यहाँ पर जो dl वेक्टर होगा that is tangential. We take dl vector tangential at that point on the circular coil. So here the dl vector is outward. In this point dl vector is outward perpendicular to the plane of board, and here dl vector is inward. So here dl vector is dot means outward, and here dl vector is cross means inward. Now we join this dl vector to this point P. This is r vector. Then r vector is in the plane of paper like that. R vector is in the plane of paper and dl vector is perpendicular to the plane of paper. So r vector and dl vector are perpendicular to each other. So the angle between r vector and dl vector is 90 degree. And in vector form of Biot-Savart's law, we write that direction of dB vector mu naught upon 4 pi I dl vector cross r vector divided by r cube. This is the vector form of Biot-Savart's law. Here in this by this formula we can say that the direction of dB vector is perpendicular to the plane made by dl vector and r vector. जो यहाँ पर ये dl वेक्टर और r वेक्टर दोनों मिलकर जो प्लेन बनाएंगे, db वेक्टर का जो डायरेक्शन होगा इनसे बनने वाले प्लेन के क्या होगा? परपेंडिकुलर. Then this is dl, this is r. We rotate our fingers from dl to r. Then thumb shows the direction of db vector. So db vector is perpendicular to the r vector like that. When we take magnetic field due to this dl vector here, then this is db vector. This is horizontal line, this is vertical line. This is point P, this is point O. This point is M and this point is N. So OM equal to ON equal to capital R. OM equal to ON equal to capital R, radius of this circular coil, and MP and NP equal to small r, distance of the line element from the point P, and OP equal to X. If we find the relation between these three, then this is a right angle triangle. This angle is 90, and we assume that this angle is alpha. If this angle is alpha, then this angle is 90 minus alpha, and our dB vector is perpendicular to R vector. So if this angle is 90 minus alpha, then this angle is alpha, and this OMP becomes a right angle triangle. So hypotenuse R equal to perpendicular square, capital R is a perpendicular, and base is X, base square under root. Under root means 1 by 2 power. Now we do the component of these dB vectors. Then component, this angle is alpha. So component in this direction is dB sin alpha, and in this direction is, see in the diagram in the notes, dB cos alpha, like that, dB cos alpha and dB sin alpha. So sin alpha components are in same direction and cos alpha components are equal in magnitude and opposite in direction. So they are cancelled out. So we can say, or we can prove by this diagram, that the magnetic field at this point P is only in the axial direction of this current carrying circular coil. In the perpendicular to the axial direction, magnetic field is 0. Okay, dear students. So by this diagram we can say that magnetic field is only in the axial direction of the this coil. Okay, derivation we take in next week.